So good afternoon, everyone. Thank you for joining us in person, and thank you to those of you joining us here on Zoom for today's Lunchtime Expedition presentation of 2022. We have an incredible speaker today that we've wanted to host since 2020, but due to the pandemic, we thought, and the interest of this subject, both to the audience here and the local community, we thought it would be a disservice to do this program virtually. So we're really excited that we finally got our speaker here today in person for you all. My name is Corey Yanko. I am the interim curator here at the Draper Natural History Museum at the Buffalo Bill Center of the West. And my colleague Sam Hanna is up in the AV booth running the questions from our online audience. So a huge thank you to Sam. Quick announcement, and this one's really timely. Please silence or turn off your cell phone and electronic mobile devices. We want to take a minute here to thank our sponsors, Sage Creek Ranch and the Nancy Carroll Draper Charitable Foundation, who make our Lunchtime Expedition and Draper After Dark programs possible. We also want to thank all of you for continuing to support us by coming in person, attending online, submitting your questions, submitting speaker suggestions. All of this helps improve the programs we deliver to the public. If you'd like to be added to our email list, just come find me afterwards. We'll get your name down, and every month I send out a MailChimp listserv announcement that has details on our upcoming speaker. All of our lectures are recorded, and they're usually available up on YouTube within a week of the presentation, sometimes a couple days if we can get to it sooner. All you have to do is go to youtube.com, type in Draper Natural History Museum, look for the bear logo, and you will see a playlist of our Lunchtime Expedition speakers. Today we're going to hear from Dr. Frank T. Van Manen, Supervisory Research Wildlife Biologist with the U.S. Geological Survey in Bozeman, Montana. He's the team leader of the Interagency Grizzly Bear Study Team, a science consortium of federal, state, and tribal agencies established in 1973 to address research and monitoring needs regarding the greater Yellowstone grizzly bear population. Frank earned an MS degree in biology, I should have asked you how to pronounce this one, Wageningen University in the Netherlands in 1989, and PhD in ecology from the University of Tennessee in 1994. He researched black bears, red wolves, Florida panthers in the southeastern U.S. during the 1990s and 2000s and moved to Bozeman, Montana in 2012 to join the Interagency Grizzly Bear Study Team. Frank has collaborated on bear research projects in Ecuador with Andean bears, Sri Lanka with sloth bears, China with the giant panda, Malaysia with sun bears. He was elected president of the International Association for Bear Research and Management from 2007 to 2013 and has served on its executive council for 15 years. Arguably the foremost authority on the grizzly bear recovery efforts in the GYE, please give Dr. Frank T. Van Manen a very warm welcome.
Well, thanks, Corey, for that wonderful introduction, and I wanted to express my thanks to the Draper Natural History Museum as well for hosting this wonderful event. And for all of you to be here in person, it's wonderful to finally be able to do this event in person. So I'll jump right in and start with the presentation. And there's really three parts to the presentation today. I wanted to give a little bit of history on grizzly bear recovery in the greater Yellowstone ecosystem. Spend most of the time talking really about the biology and science behind that recovery, and then we'll spend a little bit of time towards the end to kind of look at the future outlook for this population. First, kind of a big picture view. This is from a map that we published last year in the book Bears of the World. So it's one of the most updated information that we have right now on the current and historic distribution of grizzly bears and brown bears and grizzly bears, the same species in North America. And what you can see there, first of all, is the green area is the currently occupied range, and you see that the greater Yellowstone ecosystem is the most southern portion of that range, and it still remains an isolated population. We'll talk a little bit more about that later on. I will point out, in terms of historic range, was mostly in the west, of course, but there's this one area where there's some evidence of historic presence of brown bears in that northern portion of Quebec and Labrador. So a little history, that was on purpose that I used that word. It really, you could start the story at whatever point in time, but I think a proper point in time is to really talk about the incredible pioneering research that John and Frank Craighead did in the Greater Yellowstone ecosystem. And there's in the 150 years of Yellowstone exhibit next door, there's a reference to that. They were really the first ones to pioneer radio telemetry. They were also some of the first people to pioneer satellite imagery and habitat mapping and things like that. So our field of wildlife science owes a lot to John and Frank Craighead for their pioneering work here in Yellowstone National Park on grizzly bears. That started in the late 50s. In 1963, a famous report came out. It's referred to as the Leopold Report. And that report really looked at the need for national park management to become more natural management. There was still a lot of, as we're all aware, in Yellowstone National Park, there was at that time a lot of artificiality, and that included having bears feed in open pit garbage dumps. And in 1967, then Superintendent Anderson decided to implement the recommendations from the Leopold Report. The culling of elk and bison herds was stopped at that point, but also the open pit garbage dumps were shut down. And there was a big controversy at the time between the Craighead brothers and the National Park Service whether that should be phased in or whether that should be done abruptly. I'm not going to go into too much of that controversy, but I think the evidence really shows that shutting them down abruptly and not phasing that out over time was the right decision. Otherwise, you would have had generations of bears that would still be reliant on these open pit garbage dumps. But because of all that controversy, the Secretary of Interior at the time, in 1973, well, I should back up a lot of bears died as a result of the closing of the open pit garbage dumps. They suddenly ran out of an important high-calorie food source, and they went all over the place, and a lot of bears had to be removed. In a time span of about 5 years, that meant about 229 bears were removed. So that created, of course, a lot of concern about a population that was already some uncertainty about how well it was doing. So Secretary of Interior appointed the National Academy of Sciences to really look at what is the situation with Yellowstone grizzly bears. And one of the recommendations from that work in 1973 was the establishment of the Interagency Grizzly Bear Study Team. But it also became clear that the population was fading away. The estimate of that report of the population at the time was 136. That is probably an underestimate. There were probably more bears than what they estimated at the time. But either way, the population was not doing very well. And that was the reason that the Department of Interior listed all grizzly bears in the lower 48 states as threatened under the new Endangered Species Act at the time. So that was in 1975. I mentioned that one of the recommendations from the National Academy of Sciences report was to establish an interagency grizzly bear study team, an independent science team with scientists from the various state, federal, and tribal agencies to work together, combine resources to really study the population in this expansive ecosystem. And so we currently have 8 member agencies, federal, state, tribal, and our goals are really to monitor the status, trend, and distribution of the grizzly bear population, to determine food habits, habitat use, look at the effects of humans and land management on various activities of grizzly bears. So those are broad objectives, but that's kind of what our primary focus is from one year to the next. In terms of our population monitoring, from the beginning, we focused on females with cubs. In the early days, capture was not really possible. Radio telemetry was not allowed at the time for a while. And so the focus was on observing the most identifiable segment of the population that was females with cubs. And that has continued to date. Later on, we started putting in more effort into capture and telemetry, and a big part of our annual field efforts among the participating agencies of the Interagency Grizzly Bear Study Team is really focused on capture and telemetry. And nowadays, of course, we have satellite tracking that really has facilitated monitoring of the population, has really expanded our knowledge of the population as well. Now, an important early finding from the work of the Interagency Grizzly Bear Study Team was that it became obvious that adult female mortality was too high for the population to increase again. So the population actually decreased well into the early 80s. That there was a definite negative trend, and so there was really kind of a perilous situation for quite a while. But the early signs indicated that was the primary factor. We need to increase adult female survival to have any hope of this population recovery. Another implication from that early work was that we need to find a mechanism to implement this science and reverse that trend. And there was a lot of discussion about how to best do that. And that's where the concept of an Interagency Grizzly Bear Committee came about, which is a policy arm of this whole setup. And members of the executive council of this committee are high-level agency executives that can actually make decisions that can change things on the ground. So these were the people that were involved in this committee had the ability to tell within their agency, whether it's the Forest Service, the National Park Service, or another agency, to change management on the ground. And that turned out to be a pretty effective strategy. So the way this has actually worked so far in terms of bridging science and policy, which is always a real challenge, we do the research, we supplement, we provide the research findings to the policymakers on the Interagency Grizzly Bear Committee, and they can then implement that within their management as federal, state, and tribal managers. And I think this is actually quite a recipe for success. It automatically and quickly allows using the science and translating that into management action right away. So that led to a broader grizzly bear recovery program, not just for the Yellowstone ecosystem, but for other recovery zones as well. That was really focused on, first of all, reducing adult female mortality, establishing habitat standards. That meant limiting motorized access in some areas, retiring livestock grazing allotments, and setting standards for the number and the areas of developed sites. It also involved responsive conflict management that is primarily done by the states. And the states have done a tremendous job in responding to an increasing number of conflicts, as you'll see later on. Information education is also an important component of the recovery program. There's a lot of, especially early on, there was a lot of misconceptions about this animal, and information education campaigns have really helped with it. And of course, the research and monitoring has been a key component of all this as well. The U.S. Fish and Wildlife Service, in a revised recovery plan in 1993, established 6 grizzly bear recovery zones. We have the Yellowstone recovery zone, of course, but 5 other ones, the Northern Continental Divide, where we have about the same number of bears as in Yellowstone right now. We'll talk about those numbers later on. Cabinet Jack has about 55 bears. Selkirk's combined, that is an area that goes into Canada actually. There's about 85 bears there. And there's really no resident bears in either the North Cascades or the Bitterroots. There's a few observations in recent years in the Bitterroots, but those are really not any resident bears yet. So let's talk some more about the actual biology behind the recovery and some of our more recent findings that relate to that. And Before we get into that, it might be helpful to quickly review the typical grizzly bear life cycle, which is a 3-year cycle. And we'll start out here in den emergence. That's usually anywhere from March through April, sometimes early May. Mating season will occur next. That is typically from May through early June, July. Then for bears, this period of hyperphagia is really critical. That's when they put on a lot of fat storage for basically for surviving the winter period through hibernation. So that is, for bears, this period of hyperphagia is where they consume a lot of foods, and we'll talk some more about that. And then entry follows, and this is what's really interesting. A female that may have mated in May or June actually has delayed implantation of the fertilized egg. And so the fertilized egg divides a couple of times, and then we call that the blastocyst stage. It floats around in the uterus for quite a while, actually, until around November, early December, when it actually implants in the uterine wall and starts developing. So this means that when the cubs are born in late January, early February, they've only had technically only about 8 to 10 weeks of development. That's why they're so small when they're born. Then when the cubs come out of the den, that after they're born, they stay with the female as cubs first for the first year, as yearlings for the second year, and then when they're 2-year-olds, that's when family breakup happens in early spring. And so that's why it is a successful cycle like that it takes about 3 years. So that's a long time period, especially if you consider that the first age of reproduction is about 5.8 years for females in this ecosystem. So what we have seen, this is based on some of our latest monitoring methods. We have changed methodologies recently, and what we have witnessed is a pretty remarkable recovery with these estimates of annual population growth are by a decade. And so you can see in the 90s, we really had a big bump in population growth. That was kind of a peak here, and then a peak period, and then it started kind of slowing down in the early 2000s. And in recent years, we've again seen a little bit of an uptick in that growth. But that slowing down in the early 2000s is certainly something of interest to us, and that's something we'll talk about here in a minute. So our population estimate for last year is 1,064 bears. That's probably higher than some of you might have seen in the past. When our previous estimates were a little bit more in the lower 700s, and that is not a result of a change in the population itself. That's simply a result of our methods improving and being more accurate. We spent a lot of time and a lot of effort in the last couple of years to increase the accuracy of these estimates, and that number is we believe, much more closely aligned with what the real population is. Of course, when you have a population increase like that, you also have range expansion. And one thing I want to point out before I start this animation is there's a couple of boundaries that are helpful to refer here. That's this national park boundaries in black. The yellow boundary is the Fish and Wildlife Service recovery zone, and then the blue boundary, that is what we refer to as a demographic monitoring area. That is the area, it's about 50,000 square miles. It's a huge area, but that's the area basically where most of the suitable habitat is, and that's the area where we're monitoring the population. We really don't have the capacity to monitor the population beyond that boundary. So when later on in the presentation I mentioned demographic monitoring area, that's what it's referring to. And as you can see, that range has expanded substantially during the last couple of decades, and basically tripled from where we were starting in the 70s. That also means that in some areas, density of grizzly bears has increased as well. So here we have the same, we're showing the same boundaries that I just showed you. The lighter colors of these cells refer to areas that have higher densities, and if you go by decades, from 1990 to 2000 to 2010 and 2020, you see that in some areas densities have increased quite a bit, and not just in the national parks, by the way. Even in some areas like here, some of the national forest areas, we see pretty high densities. Now, why do I mention that? It's because this is where some of the internal dynamics of the population start playing a role. That slowing down of population growth that we witnessed in the early 2000s, that is actually a result of lower cub survival in areas with higher densities. So when we look at this density index, we see this slowing of population growth in the early 2000s. That is one reason for that is that it's related to lower cub survival, and more so in areas with higher densities. So where densities are higher, cub survival is lower. That results in a slowing of population growth. And that has been observed in many other brown bear populations. Certainly in Scandinavia, there's a long-term project there too, where they have observed that in Alaska and other places as well. And there's different ideas about what the actual mechanism is behind it. But the reality is that in higher density areas, younger animals like cubs are just very vulnerable to getting killed by male bears, for example. And that, again, there's different the hypotheses behind that. I'm not going to get into that. But the reality is that what's driving this in high density areas, cubs and younger animals tend to be more vulnerable to aggression from other bears. Let's look at body condition and diet. We have some standard tools available to us to just measure body mass, body weight, but we also have what we call bioimpedance, where we could actually, that's this little machine here that we can hook up to the bears and actually estimate how much of their body is made up of fat, so percent body fat. And you know, this is what we always say, this is what a bear strives to be, right? This is their goal in life, to be as fat as they can right before hibernation so they can make it through the winter period when there's no food around, and still have hopefully some fat storage by the time they come out. And you know, males and females have somewhat different strategies in building up body mass. And this is a graph of lean body mass, so this excludes percent body fat. But what we see is that basically females start plateauing out at about age 7, but males don't start plateauing out on that until about age 14. And the strategy of males is, of course, to build up as much bulk as possible, because that gives them the reproductive edge in competing with other males for mating rights with females. So, males in this age category are really in their prime, and this is where females really start reproducing as well. So they're slightly different strategies, and the male strategy is really to bulk up in a sense. In terms of the annual change body fat is a big factor. We actually see that bears lose body fat in the early months after hibernation, so they're still using some of that reserves that they have, and they don't really start gaining it back until starting in about June. Now, this is important because for females, researchers at Washington State University have found out that females that are pregnant could successfully reproduce if their percent body fat by the time they enter the den is about 20%. So if it's higher than 20%, they typically are successful. If it's below 20%, if they have not been able to gain enough body fat, even if they're pregnant, they may not actually produce a healthy litter of cubs. So for females, that body fat percentage is important. So then the question is, as a bear, how do you get that? How do you build up that percent body fat? And you might be wondering, well, your big male like that is not going to do it on munching on some white clover. But believe it or not, it is in this top list of high caloric values. Which one do you think is the top one in this list? Anyone want to take a guess? Some of you already know. Army cutworm moths. They're just an insect that on a per gram basis, they provide the most calories. And of course, vertebrates and fish and that type of thing, and of course, whitebuck pine seeds as well. So let's cover a couple of these high-calorie foods that bears consume here in the Greater Yellowstone ecosystem. And whitebuck pine seeds are certainly an interesting and important one. They have about 52% fat, and the rest is kind of equal between carbohydrates and protein. So it's an important source of food. And bears rely on red squirrels for caching those seeds, and they dig up the middens that the squirrels create and basically get the pine cones that way. So pretty smart. Not good for the squirrel, I guess, but if you've seen these middens, they're huge. These squirrels are amazing in building these middens. And these are remote camera photos, by the way. These were not taken right at the site. These were Jake Davis made these with a remote camera. And bears will seek out these midden sites in the fall to find those whitebuck pine seeds. Now, as many of you are aware, we have seen a pretty substantial decline in whitebuck pine in the ecosystem, primarily related to mountain pine beetle, which is a native species that can affect whitebuck pine trees, mature trees especially, pretty well. There's also blister rust and fire that might influence whitebuck pine mortality. But 75% over the decade of about early 2000s, 75% of mature whitebuck pine trees have died. And we have seen a response of grizzly bears to that change in the system. They are not selecting for whitebuck pine as much as they did in the past. They delay their use of whitebuck pine stands by about a week. But it's still a valuable resource. There's still stands out there that produce whitebuck pine seeds and that bears are using. We also found from that research that about 1/3 of bears actually didn't have any whitebuck pine in their fall home ranges. So that indicated that whereas we initially thought that whitebuck pine might be a critical resource to bears, it indicated that maybe it's not. Maybe there's plenty of bears that apparently can do without. And one reason for that is that there are lots of other choices for bears in the fall during that period of hyperphagia. Army cutworm moths, in this region, of course, you're very well familiar with that system probably, where bears are feeding in these talus on army cutworm moths. And each blue arrow here is pointing at a little black dot. Each one is a grizzly bear feeding on army cutworm moths. And basically it looks something like this. This was on Frank's Peak. These bears go up there early in the morning. The moths will use these talus slopes to basically as a thermal refugia. They feed on nectar of wildflowers in alpine meadows during the night. Then early morning they move to these talus slopes to basically for thermal refugia during these hot summer days. That's where bears find them and eat about 40,000 of those a day on a good day. 40,000 moths, that's a lot of effort. And this is what they do all morning long. It's an incredible system. Predation and scavenging is also important for grizzly bears, and they're actually pretty good predators. We have witnessed incidents where grizzly bears can kill a healthy bull elk like this one, chase it into the river and get to it. Bison in some instances as well, so they are good predators, but they certainly also take advantage of carcasses when they are available, especially after the winter time. Winter-killed carcasses are important. Used to be more important for grizzly bears than they are now, probably. That's partially due to changes in elk herds and things like that. But whenever you have a carcass, there's usually not just a single bear that is interested in it. As you can see here, there's actually 3 bears in this photo at Pelican Valley. And that results in some really interesting interactions. And this is a video that Kerry Gunther with Yellowstone National Park made with remote cameras on 3 male bears on a bison carcass. Pretty impressive, isn't it? And in some instances, this is a photo from 2007 in Hayden Valley. There were 20 bears hanging around this one bison carcass. Now, I mentioned satellite telemetry and GPS telemetry before. We're getting some really cool insights from using that type of technology. And one thing we're seeing, for example, is we can use the GPS where we see clusters of GPS locations. We typically can identify that as, some activity that's going on. A lot of times that's associated with a carcass. So in this case, you have these red dots mean locations where the bear was active, and the yellow dots were locations where the bear was inactive. So you see a bear's on the carcass most of the time, and it seems to be pretty active there. It's actually feeding, and then it goes to a daybed, mostly inactive locations, and it goes back and forth. Now, some bears will decide to do that all in one place. Instead of going back and forth, they just are active and inactive right on top of the carcass. And so you see some interesting differences in behaviors. And by the way, we have some evidence that bears may detect a carcass like this from a distance of 10, 15 miles away. We've seen some straight line distances of a bear moving straight to a carcass across a span, distance span like that. So their olfactory sense is just amazing, and they can find these places. So this is typical of the last example, where a bear basically feeds on the carcass and stays right on top of it the whole time. Now you may be wondering, what are we doing with this barbed wire? Are we trying to keep this bear in one place? We're not. This is for some genetic sampling, where we can collect hair from a barbed wire like that and actually identify the individual bears this way. But this is obviously a time lapse, but you can see this is not uncommon for a bear to just sit on a carcass like that. And so with the decline of whitebark pine, what we have seen during that same time period of early 2000s, we've seen an increase in carcass use by grizzly bears. So they're finding an alternative to whitebark pine in the fall season. And from a lot of work we did about 10 years ago, looking at diets, we documented, and Kerry Gunter did a great job of looking at old historic records and identifying how many different food items bears actually consume. And this is not that each bear consumes 260 items, but as a population, we have documented more than 260 different food items. That's an amazing number of species that bears consume, and so also indicates that bears are really very flexible in their diet. And what we found was that their diets differ from day to day, from season to season, from year to year, from area to area. Depending on where you are in the ecosystem, you have a different feeding economy, and they also differ among individuals. Bears are just as individualistic as you and I, and that's also reflected in their diets. A good example is this bear that tore down a yellow jacket nest and decided to just eat the yellow jackets. I've never seen that in grizzly bears. I've seen it in black bears, and it's amazing to see them forage on yellow jackets and bees. They do get stung inside the mouth, in the tongue, and they make these funny faces, but they stick right at it. Now, one question we still had lingering that we just recently addressed was, okay, so they're changing their diets, they're shifting diets to accommodate other food resources, but are they still able to maintain body conditions? So we looked at percent body fat, and we looked at the rate of body fat gain starting in June through the end of the active year before they start hibernating, and see, is it different during that decade where we've seen a lot of changes in food resources, so the 2000 to 2009, those are the round ones, and that's the darker color here, versus the decade after it. And we found out that the rate of percent body fat gain was really the same. So bears were finding the same number of calories that they used before, despite substantial changes in the ecosystem. That's true for females, and that's true for males. So that was really encouraging news to know that somehow these animals remain pretty resilient in dealing with that. But what we did find, and again, it comes back to density, we did find that female bears, this is a graph for females, female bears in the mature phase, their lean body mass is the same regardless of what area of bear density they are in. But for female bears in the growing phase, in higher density areas where there's more bears, they have a lower lean body mass. So they can't quite reach the typical body mass of other animals. And that might have some implications for the future. That might, for example, affect their reproduction. That's something that we still want to look into further. But that's a really interesting finding. And it's a type of finding that you really can get to with short-term studies. So these long-term studies in an ecosystem like this, where bears have good longevity in places like the national parks, where densities are high, this is where you can study these type of dynamics. Let's talk a little bit about genetics. There's been quite a bit of controversy and discussion about that, and you got to give it to these two bears. They picked a nice place to mate. Pretty romantic there in Grand Teton National Park. And in terms of genetic diversity, one measure that we use for measuring genetic diversity is heterozygosity. And when you look at this across North America, so this is looking at it latitudinally from south to north, healthy populations, contiguous populations in the northern part of the range, but less so on the southern end of the range. And Yellowstone is pretty close to the lowest end. There's one, the southern Selkirk population has lower genetic diversity than Yellowstone, but it is something that is of concern. However, it has not changed much in the last 25 years. Genetic diversity has not declined. And there's really no evidence that, even though it's a little bit lower, that it's a major concern for this population. We've also looked at how what we call the effective population size has changed, and that the effective population size means the number of bears that are contributing genes to the next generation. And what we see here is that there's two important thresholds. One is an effective population size of 50 that is enough to prevent, if you're higher than that, it's enough to prevent inbreeding. When you get close to 500, that really allows you to have long-term genetic viability. And one of the techniques, all of the techniques that we used showed increase of the effective population size, and in this particular one was actually getting close to that magical number of 500. So I'm not that concerned about the genetics of the population, and it's also something that we could probably resolve through translocations if that were necessary in the future. The other aspect of this is that we may soon have natural connectivity with the Northern Continental Divide ecosystem. This is a southern portion of that. The diagonal lines are occupied range. The blue areas is what the Fish and Wildlife Service recently mapped as what we call maybe present. So areas where there's enough verified bear records that would qualify as bears may be present there. We're just not really sure. But when you look at the distance between these two ecosystems, there's only about 37 miles left there. And that's certainly a distance that a male bear can bridge pretty easily. So we may be on the cusp of actually having natural introgression of genes from the Northern Continental Divide population. Now, we actually looked at potential paths that male bears could take to get from the Northern Continental Divide to Yellowstone. And this is what that looks like. The darker areas is where there is more likelihood of bears passing through. And so the Bridger Mountains on the north side of the Yellowstone ecosystem, the Tobacco Root Mountains, they look like pretty pivotal points for those type of connections. So we've learned a lot about this population, and I think it's important to point out that, and the exhibit next door makes reference to this as well. The places like Yellowstone National Park, Grand Teton National Park, and the National Forest, and a healthy ecosystem around it allow for these type of investigations at a really large scale. So they're kind of like natural field laboratories to really look at some interesting aspects of bear biology and ecology. So by all means, this, from a biological standpoint, this is a recovered population, and it's, I think, helpful sometimes to look at, why was this a conservation success? And there's a number of factors that contribute to that. First of all, we had the organizations and people to manage the conservation program. Agencies and interagency cooperation was really important. We had the biological data from the study team. We also had really good political support. In the early days especially, there was no politician wanted to see this population go extinct on their watch. So that was helpful. And of course, public support has been tremendous. Public engagement has been really good. Public input has been good. Not everyone agrees within the public, but that's okay. There's been great discourse about what what a recovery for grizzly bears should look like, and that continues to date. And let's not forget the importance of protected areas as well. You know, we have these big core protected areas that make a huge difference for these wide-ranging species like grizzly bears. But let's also not forget that we should give bears credit as well, the bears themselves. And this is a quote from the 1982 Fish and Wildlife Service Recovery Plan. And I came across it recently again. I'd seen it before, but I thought it's very applicable for the point I want to make here, is that these animals are pretty resilient. If we give them a chance, they can make it, as long as we can maintain that adult female survival that's high enough for them to not decline. And you know, can everyone read that okay? Otherwise I would read it to you. So this really I thought was a very telling quote that speaks to the species itself. So in the last part, I want to talk a little bit about the future outlook for this population. And by the way, I'd like to thank Jake Davis for letting us use his photos. He makes great photographs. He's very generous with allowing us to do so. Of course, with recovery success, there are also some challenges, unfortunately. And if you look at the number of conflicts within the recovery zone, they've actually been pretty constant, as you can see. That's a relatively low number, because within the recovery zone, 98% public land, you have a lot of control over the situation and preventing conflicts between humans and bears. But once you go outside of the recovery zone, you have more private land, you have more mixed use, and especially once you go outside that demographic monitoring area where you have a very different landscape with much more human influence. Especially in the last decade, we've seen a pretty substantial increase in human-bear conflicts. A lot of those involve cattle depredations, and you can imagine these could have serious impacts on ranching communities. And so this is presenting a real challenge for managers. You know, how do you deal with this increasing number of conflicts? And it's not just livestock depredations. There's also other hunters encountering more bears in the backcountry while they're hunting, elk hunting, for example. So those are certainly challenging concerns. And of course, what goes along with that is that with removals and people occasionally killing bears out of self-defense, we've seen, as the bear population increased in occupied range, we've seen mortalities expand as well, and the number of mortalities increase. About 85% of all mortalities are a human cause. And of course, we have also the issue of climate change coming up. That is something that we're interested in, and really don't have a lot of information yet in terms of how bears might respond to that, so I'll provide a few perspectives. This is from a recent Greater Yellowstone Climate Assessment. It was a big effort among a number of agencies, and Montana State University, U.S. Geological Survey was involved as well. And we're looking at, I'm not going to get into too much detail, but the black line is basically where we are, the actual measurements. The red and the blue lines are projected measurements, or projected projections for temperature and snow water equivalent. And as you can see, in a more optimistic scenario, we're still looking at quite an increase in temperature in the Yellowstone ecosystem under a pessimistic scenario. And currently, we're on track for this scenario. We're looking at some pretty big changes temperature-wise. Same when you look at snow water equivalent. But in the other direction, of course, with maybe less so available by 2100. So that's a concern. Now, I think bears can actually deal with heat stress pretty well. We actually did a project a couple of years ago with the University of Idaho and Washington State University and looked at that. And they mapped out grizzly bear heat stress. This is for females that are not lactating. But what you can see here is if they don't have access to water, only the July midday period is kind of where you see these areas in red where there might be some concerns about bears having heat stress. But that is making an assumption that bears don't have access to water. Even in future climate scenarios, I think most bears will have access to water, and that's what you see at the bottom here. And in that case, I don't see a real concern that bears will have issues responding to climate change in terms of heat stress. What might be a factor is regeneration potential of forests. How is the habitat going to change under different climate change scenarios? And if forest regeneration changes, and these areas in red, again, under different optimistic versus pessimistic scenarios, these areas in red would have a higher potential for regeneration failures. So what happens if forests don't regenerate? How is the habitat going to change, and how is that going to affect bears and lots of other species, of course? And on top of that, we have to wonder, what is the human situation? What is the human impact on this ecosystem going to look like? Because we have people everywhere, especially since the pandemic. It seems like people are popping up in places where you didn't necessarily see them in the past. When you look at the national park visitation, these are the most recent numbers from the National Park Service. Yellowstone National Park, almost 5 million last year. Grand Teton National Park, almost 4 million. Those are huge numbers, and that's just the 2 national parks. There's also a lot of visitors to the national forest. So there's a tremendous human pressures, recreation pressures on this ecosystem. And then we have residents, and number of the population housing has increased. As you can see, the blue line is the population, historic resident population, and the red dots are number of houses. Well, this is what Andy Hansen at MSU, at Montana State University, predicts could happen by 2050. Well, that is a substantial increase in number of people residing within this ecosystem of, with the 20 counties that are comprised of that are within the ecosystem. And of course, with more people, we will have more traffic, more accidental deaths like this, more encounters between grizzly bears and people that could result in bad outcomes. So one way to think of this is work that my predecessor did more than 10 years ago. But one way to think of the implications of all this is to think of this in terms of what we call source sink dynamics. And what you see in this map is these darker areas are areas where female survival is too low to sustain a population. So it's below a threshold for positive growth. In these lighter areas, female survival, and this is based on a lot of spatial modeling, female survival is high enough to sustain a healthy population. As you can see, these black boundaries are federal lands, the Park Service and then Forest Service lands. Most of those source areas would be confined to public lands. That dynamic is probably going to play out more strongly in the future with some of the projections if they end up being true in terms of human occupation and number of houses in the area and increase in traffic volumes and things like that. So that raises then the question, how many bears is enough, and where do we want bears? Because that is kind of the question we're facing right now. We have successful recovery, but how far can we expect bears to be on the landscape? We probably don't expect that we can have grizzly bears right in the middle of Cody all the time, and other places around here. And so some of these questions can be addressed by science. Science can address how many bears you would need for genetic viability, for demographic viability, and things like that. And my answer would be we're there at this point. We are there with that recovery. But in terms of the question of where do we want bears and how many bears do we want, there's also a lot of public opinion, and those vary, of course, depending on who you talk to. because some people are impacted more by the presence of bears than others. And so what that means is that we probably need to have a broader conversation about what recovery looks like beyond the kind of established boundaries that we have bears in right now. So to summarize the key points, the U.S. Endangered Species Act was a key instrument in the recovery of this population. In 1975, the listing of this population, that made a huge difference. The interagency science directly informed what that recovery should look like. And then there was what I would refer to as really visionary management that I think is a great example of how conservation can be approached by agencies collaborating, relying on the science, and working together to make changes on the ground that really change the course for grizzly bears. Of course, the species biology has a lot to do with it too. They are actually pretty resilient animals. They're more tolerant of humans than we sometimes give them credit for. And I think that's another factor that we should not ignore in all this. And we should, for future consideration, I think we should start looking at a management framework that links biology of the species with socioeconomics, that looks at, okay, what is the value of bears to people? What are the costs of having bears to some segments of our society? What is the potential for land change, climate change to affect all that? That will be quite a challenge, but I think if we use the same approach, all entities involved should be up for that challenge. And with that, I wanted to leave you with a synchronous bear rubbing video. It is pretty remarkable how synchronous it actually is. I think they even, see, come down at the same time. So that one had an extra itch. I want to thank you for being here, being present today. I also wanted to thank the online audience. This was a contribution from the Interagency Grizzly Bear Study Team. A lot of people are involved on the study team itself, and we benefit from tremendous volunteer effort and agency efforts that support our work. Without them, we wouldn't be able to do all the work that we do on behalf of grizzly bears. So with that, I'm very happy to answer questions.